Alright, so we're back. I'm going to try another problem, and I don't know how this is going to go, but I wanted to quickly look at another question, have some time before the Bible study. It's going to start a little bit later than I thought, so we can do that, and that's all well and good. We'll get that going. Let me pull that up. Integer replacement. Let's see how we do. Given a positive integer n, you can apply one of the following operations. If n is even, replace n with n over 2. N is odd, replace n with either n plus 1 or n minus 1. Turn the minimum number of operations needed for n to become 1. Oh, no kidding. Okay. Whoa. So I want to say... This is very similar, by the way, to the, the Collatz conjecture. If it's odd, you can either go up or down. Add 1 or subtract 1. It's even, it's n over 2. So a few things about this. This question, I don't anticipate this being a particularly difficult question. Reason being, this operation is very obviously going to be logarithmic, right? Because you're only adding or subtracting a 1, making this even at every odd step, and you're either doing a logarithmic number of operations or sort of an additional operation between your logarithmic operations, right? So this is, you could basically count directly how many operations you need, and pretty much what you can do is, because it's only going to be a logarithmic number of operations, then you can do like recursive memoization to get you can do recursive memoization for each decision that you make and find out what the optimal is. It shouldn't be too inefficient. Yeah, let's try that. Let's give it a shot. Let's see how we do that. Let's see how we do. I wouldn't use dynamic program. This is a form of dynamic programming, but I wouldn't use the it's a form of dynamic programming. I wouldn't use the excuse me, I'm just a few things to think about here. It's a form of dynamic programming. I wouldn't use a vector of values for this because the number of decisions that you would make, there are kind of a lot. Or rather, no, they don't fit nicely into a vector. They do fit. It's okay to put it into a map, but this is more of like a yeah, this is kind of, in my opinion, better off done just recursively, or yeah, I think recursively is fine. So it's actually, I don't know. I'm thinking about it. I don't actually know how this is going to turn out. I think it's fine. I think as long as it takes a logarithmic amount of time, then I think we can show us the logarithmic overall. But anyway, so okay, so we'll say base cases if n is less than or equal to 1, then return 1. Minimum number of operations for n to become 1. I think it's actually 0 if it equals 1. And n is, yeah, we could say less than or equal to 1 is 0. That should be fine, I think. 2 divided by 2 would give you 1. 3, you could add 1 and divide by 2, or subtract 1 divided by 2. Yeah, something like this. We'll do less than or equal to 1. and we're going to say if n is odd, or n and 1, right? So if n and 1, if that's odd, we're going to do something. If it's even, so if it's even, we're going to say f of, that's x instead of n, by the way, x over 2f. We're going to say return this value plus 1, right? Because we have one operation to do. And we're actually going to say, ret equals this value. Memo of ret or x equals ret. Return ret. Okay. And otherwise, we're going to say int a is f of x plus 1, and int b, actually, is x minus 1. And we're going to say ret equals standard min of a and b plus 1. Right. So this is memoized, and we said, right, if it's odd, we can add 1 or subtract 1. We're going to pick the best of those two options, and then if it's even, we're going to just divide by 2 and add 1. And actually, we can add this 1 later. It doesn't need to happen here. Right. Okay, let's see how we do. Thank you, compiler. Whoops. Do that. Oh, we're okay. Error ret. Right, okay. I guess ret 0 initially. And what am I missing here? Oh, yeah. Want to memorize. Not sure how much that matters. It may or may not matter that much. I don't know. There's one more thing I'm missing. Why do I feel like I'm missing something important? I don't remember what it was that I wanted to do. That was significant. I don't remember. How are we doing on time? 8 minutes? Okay. Memo implicitly captured. Oh, yeah, thank you. I don't know what's going to happen here. Oh, okay, 4 milliseconds. All right, that's pretty good. 7, 4, and we'll say we want to use like very large numbers here. I'm going to just throw a bunch of random numbers in there. Can't believe that actually worked for some of these. Signed integer overflow. Oh no. Oh, look at that. Oh, think of that. There you go. Uh-huh. Uh-huh. Well, we can just put an if statement there. If x is less than int max. Something like that. Wrong. No. 2, 3, 4. The fourth one was wrong. 1, 2, 3, 4. No, that's that one. That's the one. That one was wrong? Really? What? That's a tricky thing, huh? Output 33, expected 32. Is that because you should actually pick this option, this add one? Oh no, you gotta be kidding me, really? That's pretty wild, man. Oh. Okay. I guess we're doing it that way then. Wow, no kidding. Alright. Alright then. Wow. No, we always need to pick this option. Not sure how I would handle that without using a larger integer. I don't know. Could not tell you. Everything except for x is an integer. Excuse me. Well, can't really get more efficient than that. 4 milliseconds. Let's go for it. Hey. Nice. Hey, 100%. Yeah, that's pretty fast solution. I don't know if we actually need to memoize, by the way. Maybe we do, I don't know. You need to go even faster too if you do this. Static. I think. Yeah, that's really fast. Well, it's fast. Let me see. Okay, let's do this. Let's not use memoization at all. Just do outright recursive algorithm. See how that goes. Still relatively fast. It's not as fast memoized, but uses less memory, I think, or it seems. Still pretty quick. It's kind of funny the way that people optimize. So this is really not necessary to do it this way, to memoize this, but it is faster. I was not sure how much faster it would be. Like I said, it's not very inefficient if it's logarithmic and what do you call that? If it's logarithmic and you have these, if each of these routines are logarithmic in the first place, then calling 2 of them isn't going to be that much more or less efficient, if that makes sense. Yeah, just the fact that we're dividing by 2 every other step, all of these branches, like they kind of have to be logarithmic, so it doesn't really matter how many of these branches we spawn, or it doesn't matter that much that we spawn 2 more branches each time, because each of these are only going to be logarithmic at worst. And yeah, not really sure how to express it exactly, other than like this is always going to be relatively efficient, even with or without this memoization. The memoization does improve a little bit, but not really that much. Alright, I'm gonna go. So, thank you for watching. That was 15 minutes almost. Yeah, it could have been a little bit faster. Interesting question. I'll give it a thumbs up. I mean, it wasn't like crazy. It's just I liked it. I don't know. It felt smart. Interesting question. Alright, I'm gonna go. Again, thank you for watching. Talk to you soon. Enjoy the rest of your time. Or I'll just say, yeah, thank you for watching. Talk to you soon. Bye.